Good morning, all of you. Let me try here. Is everything okay? My name is Alexandre Grimberg, PY1 Alpha Hotel Delta, PY1 AHD. It's a great pleasure to be here at Dayton Hamvention. It's my 10th time here at Dayton. And I brought to you my 12 years history from designing the first portable magnetic loop antenna. Okay? So, when you talk about portable magnetic loop antennas, they exist for more than 100 years. What I have done was break 4 or 5 paradigms to bring the magnetic loop antenna to the ham radio world. That is what I have done. So I would like to explain to you how I have done this and all my ham story about the development of this product. This play for me, you know, because all my designs was devoted to my great pleasure and make portable operation. I have something more than 48 years that I am working outdoors communication. This is my passion on the ham radio hobby since my beginnings on radio. I am 68 and I have started around 17. So I have here in portable something like 48, 49 years. So I've started to show now something about this history. Okay, who is Alex? Alex PY1 AHD, a Brazilian ham. I was graduated and lawyer, but my passion in electronics talks a little bit louder, you know. So here is some historic information about how long the magnetic loops antennas are between us. We have a demonstration in England in November 37. And another use on a field operation on a Balkan zone in 42. You can see easily that the magnetic loop antenna are very familiar on the strategic world. I have started my portable loop experiences 17 years ago. Here is the DNA proof that I have the very first one who started this. On this time there is no form, there's no programs, no application on the internet that you can find out. So I need to take a paper and pencil and write and rubber and take off something like a quarter of inch of the loop, more 1/4 inch. Okay, no working anymore, like make another piece of copper to make another loop, and this gone. I was drawing on the trial and error procedure. So you can see easily my handwriting notes. I have requested to break some very unbeatable paradigms to make this loop. I have used the variable capacitor. It always was recommended, extremely recommended to be on the top. This is true. The best position for the variable capacitor is on the top of the antenna. But the problem is that I was needing to make something that I can carry in the hand. So considering that the variable capacitor is the heaviest piece on this system, I need to brought it on as low as possible to have a balanced antenna to work. So I break it from the back, from the top, from the back. So the excited loop was needed to be on the bottom. The radiating loop was needed to be a solid conductor. So I was the first one to work on a coaxial cable. And the irradiating loop paradigms told that they need to be soldered to the capacitor to avoid losses. And this is the paradigm that I have broken. I bring the variable capacitor for the bottom, the excited loop for the top. The coaxial cable has a irradiation system, and a rated cable loop connected to the variable capacitor by connectors. I always have shorted the variable capacitor, the coaxial cable, to have the braid and the inner cable connected together to lower more and more the internal resistance for the irradiation. So you can see here. Here is the Brazilian register of the patent of the idea. I took these 5 paradigms and have registered there to protect my intellectual property. Here in January 2002, I have made all, if you go to the center of the image here, let me show here, if you go to the center of the image, this was my very first loop antenna. This one was made with quartz, a simple 3 to 30 variable capacitor. With this antenna, I went with a FT817 to a parking lot and could talk with a FT817 to Texas, loud and clear. So it might on 10 meters. So it was the very first time that I became very impressed and amazed with the results of this very small antenna. So I decided to make other ones here on the left. I decided to make one using, this kind of foam that the child uses on a swimming pool. It's like a spaghetti. Okay? So I have reversed this spaghetti with aluminum foil using in kitchen aluminum foil. I have passed it through. Of course, the resistance of the loop was very high, but I have compensated this by the wideness of the conductor, because it's very wide, So this one here, I have developed a very small trombone capacitor that is controlled for a system that you see in some slides ahead. Here, let me go back. Okay, here's my first try to make a low technology remote control. What you can call a low technology. This is here, 2 pieces of metal. This is a cylinder. I have here a plastic tube. I have in my hand another cylinder. All the system is filled with water. So when I press here, this part press this direction, and I have the increasing in the capacitance. So I have lowering the frequency with this. So I could remote control the system for the first time using water, This antenna is a very special try because I take 2 pieces of PC boards. With 2 pieces of PC boards, this is a very light antenna. This one weighs something like 400 grams, half than a kilogram. And this one, I take my thumb, put in this part, and I can run this board over the other board. One side of the loop is connected to the movable board, the other side of the loop to the fixed board. I have made a scale here that can be showing me the frequency. So I can, by the time, move the variable part of this capacitor and have the band changing and the frequency adjustment. Here is another evolution of the system. I take 2 PC board a syringer. I have here a scale. This part stays here on my belt. The antenna is on my back. I was holding it on my back, so I can control the frequency by this way. Now I have the coke loop. I have decided to make a magnetic loop using coke cans. And this one,
boa noite, Sebastião, boa noite, Bira, boa noite, Matos. Deixa eu mostrar para vocês aqui esse engenho aqui que eu preparei. É a loop convencional, como vocês sabem, só que o loop está embaixo. Nessa posição aqui eu coloquei uma seringa de injeção. Ela está conectada mecanicamente a duas latas de Coca-Cola Light e ela escorrega por dentro da outra. E eu estou fazendo a sintonia com isso, por isso que eu estou impressionado como é que essa tralha chegou. Se vocês podem ver agora, que aqui a frequência sobe e aqui a frequência desce. Vou tentar pegar a minha mão aqui mexendo na seringa para vocês terem uma noção. Olha aqui, a seringa abaixa, pressiona e ela volta. E aí eu estou conseguindo, através do capacitor, está vendo aqui? Olha só, de novo. Tá bom, gente? Eu vou desligar agora a seringa na minha mão, controla a frequência de ressonância. Deixa eu abaixar aqui. Então agora dá para ver mais um pouquinho. Aqui e aqui. Eu tenho mais ou menos uns 4 metros de tubo de plástico aqui. Legal, gente? Boa noite, muito obrigado pela atenção. Feliz ano novo para vocês.
Now it's the application of this idea that I have, making this small trombone. I have made this with the coke loop, and I have the opportunity to show this at Friedrichshafen Ham show, and 2 times here at Dayton Hamvention. I think most of you could see it working here. Friedrichshafen and Tokyo Ham show in 2015 in Japan, Tokyo. And now I have made a very, I have made a very light and small loop with only 688 grams, you know. This is a very interesting experience. That was something that I was dreaming for all my life. All of us that are not more boys was dreaming on the day to have something on the hand that can help us to make intercontinental contacts. All of this has Ham since a little boy, seeing the movies Lost in Space, would see this and would like to have something that you can talk all over the world holding a portable thing in the hand. So I have made this system with a very small magnetic loop applied to a 10-meter single sideband radio, handy. I have made it. Let me see here. Here is an experience on my balcony, on my apartment balcony, surrounded by tall buildings. This is contact on 10 meters with a guy in Argentina, something like 1,000 miles or more away from me.
Hola, Delta Japón Bravo, aeropuerto Delta Japón Bravo, escucha PY1 Alfa Hotel Delta. Sí, es PY1 América, Holanda, Dinamarca, Ocampa con equipo portátil, haciendo la prueba con equipo portátil, pues excelente. Alexandre, muchas gracias, ok, soy trabajando
to show that I do not have a standing wave relation meter, to adjust the antenna. So I have decided to take a node, a Kai tape recorder indicator view, and I made a bridge. Here's the sensitivity control. So I can adjust the antenna here by the intensity of the RF signal instead of a standing wave relation meter. So I can pick the signal here. And now is another one. It's my first stealth magnetic loop. This is a table, This is a table, and I have here the loop mounted on an inner board of the antenna. I have the variable capacitor here. I have the adjustments. I have an adjustment stick with a button, with a knob here, so I can adjust the frequency. The great advantage is there is nothing more disguised than this. You can put your beer here, and nobody will know that you're talking to the radio, okay? So the great problem is the RF make the ear a little bit hot. So here I show in details how I made this antenna with this capacitor, the turning button, and how it lights. This one I decided to make with a big one using this kind of metal used for chimneys. Is a chimney, aluminum chimney tube, flexible tube. The great advantage of this antenna, I use it for 40 meters, and this antenna is something like 4 inches on wideness. So these two can be proportional, something like 1/8 unit down of a standard dipole. So for a very small antenna is a very good fit. Here is the antenna inside. I have the capacitor here, and I have a flexible braid here. And I have this tube that I was talking about. Everybody knows it, Here I see the aluminum foil and polyester film. This is my first try to make a magnetic loop with a frequency indicator. I saw in the stores the people selling this kind of motor. This motor, you remember the first small hi-fi systems. They have a volume control button that you press it, but they have a motor to command to activate the potentiometers, the audio gain. So it was an all mechanic system that you have the potentiometer here, the motor here. So I decided to have this potentiometer has a reference on the position of the capacitor. So I decided to use this and make a scale on a meter. And I could here turn this button up and down and check the frequency position. Here's another control that I have developed that is a circuit to command the loop, completely mounted on a PVC stick, on a plastic PVC stick. This device here is just in case of emergency, considering that it works on a 3-volt battery to 1.2 volts nickel-cadmium batteries. I have decided to take a flashlight, with a dynamo flashlight, to charge the internal circuit just in case of the absence of energy, or in case the power goes down. And this stick was fixed by a magnet, or HD magnet, to the body of the FT817 radio. Now is the way I use it, the antenna on the back. This one with the control. I use this, and I have something to carry the magnetic loop on my back. Here was my outdoor magnetic loop, that I have made using. Let me go ahead, here. I have used it, this kind of thing here is very good for this use, because this thing here is this kind of a security light that have a sensor. When you pass by here, the light goes on. This is very good because it's shielded to the rain and humidity. So I decided to use this to the outdoor antenna, to the outdoor magnetic loop. And here, I have a 3-button mouse to control the motor of the loop. I have here to up, I have left, right, plus up, down, and can do everything to control the motor with a complete pulse width modulation circuit mounted inside a simple mouse. Here is the complete remote control command for the loop. We have here this combination, left plus center. Left plus center. I have fast down. Here fast up and slow. Only the button without the center button that increases the speed of the system. Here's another control. And Eric from KSO today have used this photograph on my profile at the kiosk today KSO. Here's another thing that we are hoping for a long time, is a system commanded by an application, an Android application. You have here, this system was developed by a friend of mine and with me, called Ricardo Caracci from the Southern Brazilian region. Now is the new version of the system. This system is not available yet because we are improving the mechanic system. The electronic and the software is already working fantastic, but we need some improvements on the mechanical system. Here we have a button that we go to the silent frequency, and here we have the fine tone, and have the fine and the main tone. Here's the main tone and the fine tone. We have 10 degrees of control, independent from the selected band. Here is the mat loop. The mat loop is here. This way here, okay? Here's the mat loop. It's a mat. It's a mat that this is the only loop that can be rolled. You can go to the beach any place with it and use as you want, Here's a tuner that goes from 7 megahertz to 30 megahertz and works beautiful. Here is, as you can see here, I have the world record, the distance record using an Alexloop with top G0 SBW. This was registered on HFPAC Hall of Fame. So the record on 70 meters was achieved on this date. Let me see here. 13, 2004 was achieving these records. February 2003. So this is the confirmation here, and this is the guy that I have told. Now he have his own Alexloop. This guy is located in England. This contract was made in Rio de Janeiro, from Rio de Janeiro, using 5 watts on Alexloop. With this guy was using a whip. It's not 70 meters. Here's the first version of the Alexloop. The Alexloop going in 2 parts, and this here is a copper tube that was squeezed on the box to easy carry, and I have to dispatch the first antennas this way. Here is the idea that I have triggered the actual Alexloop. Steve Silverman is our colleague here. Need to go to a trip at Galapagos Island and need to take a airplane, and also afraid to have problems with the people there and security. So he asked me to make a loop, more or less to be portable, to go inside a bag. So I have developed this one. This one was the model that had to trigger the actual Alexloop. Here's the actual Alexloop with all the parts inside. This is an experience on a nautic loop. And here is the Alexloop as I use on my window. Time to take the airplane to Hamvention 2004. And I was there showing to the people the magnetic loop for the first time. 99.9% of the people there have never known about the Alexloop. In other words, I was the only one to know something about this thing. You know, I was there with Silver. Let me play here the video. They're seeing for the first time the circle. Stop and cross the arms this way, stay there for some minutes. And what's going on here? Oh no, I just waiting here till the time you put fire on the circle and the dog will go through it, you know? Okay. Here is the first time that I have some place to stay there with Larry. I think most of you knows Larry from W4RB. Larry, Ralph, and Barry from W4RT. Is the first people here who believe that would, show this product. Here are the magazines that have many reviews about the Alexloop. I can show here 12, actually there are 40 magazines around the world. And if you can see here, this is the front page of the magazine that was edited in Japan. Here is Joe Walsh on October 26 on the 4th of October, the CQ magazine. Here is Spain. Here in Japan. You can see here. He was in German. Another one in German. I don't know where is the country is, I don't know what the letters means. And this is QST. A great review made by by Phil Salas. This is CK Ham showing the CK magazine that was edited in Brazil. This is Sweden. Switzerland is Ireland. Japan. Here's the people from Japan have met, they need to re-interview. Here's the Czech Republic. Here's the CK Ham in Japan, 2015, December 2015. I have been there because I made part of a group of Japanese hams that make a lot of researches on magnetic loop antenna. I have the honor, the people received me, my wife there for dinner. And there are a lot of, many people, like a guy who is working for 34 years in Sony, and have developed the Trinitron system. That one is one of the hams like us that have that allows to make and play with magnetic loop antennas. Here is the complete contest station. I have on the station everything that you need. I have a little drawer, I have like a breadboard, I have the KX3 here, a tabletop, a tablet, and I have even a small camera to record my, unbelievable contacts. So I have a camera here. Look at the camera, can be seen here more clearly. I have these with a gooseneck. I have here a touchpad, a Bluetooth touchpad connected to the system. The microphone, I have the hours from Zulu time and local time. Here I show here the details. I have the tablet here, the camera, the watches. I have a little drawer here with, afterbite. There's a lot of mosquitoes in Rio de Janeiro. I have a Swiss Army knife. Here's the camera and all the things here. Here's the tail of the system that I carry in this portable contest station. All the things that I have on the set. And here's a QSO with the system.
Papa Yankee 1 Alpha Hotel Delta QRP. Okay, Papa Yankee 1. BY1 Alpha Hotel Delta running 3 watts, okay? Running 3 watts, okay? Okay, that's right. Papa Yankee 1 Alpha Hotel Delta Alex running QRP. Let me check with my camera is working. I'm making a video, okay, Emil?
These images are made with a small camera attached to the system. You know, it's like a vehicular camera, a security camera. This one here.
Okay, I have only 3 watts here, Emil. It's unbelievable. So I like to...
Okay, now I have some photos of hams that use it at their home and make the test with the Alexloop. All of them send photos. Probably some of you are on these photos here that they send me. Here, guys, is very important because this guy is called Mike Oldbridge. This guy is from Texas, from Soda. And this guy has something like 2,400 registered QSOs using a FT817 with a small magnetic loop from Alexloop, you know. So I have 1,000 confirmed QSOs with 5 watts. This one have 2,400. More photos from our colleagues. This is a very impressive history. My daughter was traveling with his husband in Barcelona. Was in Barcelona one sunny evening, on sunny morning. When he saw something, a group of people using something like an Alexloop, and then came there, and there was a group of hams making portable radio on a square with the Alexloop. Here is Diana Miriam, my wife that comes with me for all these shows, you know, that help me a lot. He's in Japan, and he's an officer, helicopter. Here's Japan, either. Here's Guy, is a cardiologist, is a ham that makes a special treatment in case of hurricanes and all things like this. This guy goes there to help the people. There is a special name for this that I'm not figuring out. Here is my factory, you know. Here's my factory, and I have a boy and a girl that have get married and have take the rooms to be my factory. So I work at home. Here's my workbench. I make the loop steel. We are reaching near 5,000 magnetic loops. Only each are was sold 1,000 units. And here I work all the day and all the night making loops. This is my living room before the system. You can make a very simple picnic table support exactly on this way. A 4 inches tube, and a clamp, a metal clamp, and this makes an excellent portable. It's not necessary to spend some $30 or $40 to buy one. You can make one with $22, no more than this. Here is all the system on an Alexloop bag. You have here the FT817, the Alexloop, and the Vivitar tripod. Here's the way to prepare the Vivitar tripod. Here's the weight of the Alexloop in grams, and here the nozzles. So I have made a design for this antenna, so it's so light that you can hold it and you can tune with your thumb, opening a new world of excitement on our world, because it's very, very funny, you know, it's fantastic. You have the ability to have a small radio and walk and talk holding your antenna. The same thing that you make with a handy on VHF. You can make an HF, holding an antenna, tuning with your thumb, and like this. You can tune your thumb while holding it with your hand. Here is a real contact of Tom, November 2, Yankee Tango Foxtrot. Let me go there. As you know, I'm very good at this kind of thing, right? No. Now we go. Simple like this.
Thank you very much for the contact from Maritime Mobile at Best DX from Blue Knot Mountain, Pennsylvania. Over. Yankee Oscar 4 Radio, Oscar United, is that what it was?
So it was Pennsylvania to Slovenia, only the antenna and a half. Let's go there. Here was a Japan. This guy here is the man who manufactured the AOR equipment. This one, I have the honor to have, this guy has one of my fans, you know, the man who makes the AOR equipment. How I show how easy and how simple and how cheap is to make at your home portable magnetic loop antenna. Will be no more than 5 to 50, around this, a 5 to 50 variable capacitor. You have the inner grain of this. This distance here, the outer loop, is 250, is something like 100 inches, right? It's around 100 inches. And then you have here the excited loop. The excited loop is connected to the braid and to the inner tube that goes to your radio. And here you have the tuned outer loop. So it's very easy, and probably most of you have all the components that you need to make this antenna. Here is my special thanks to my wife Miriam, who is enduring my ham radio madness for 49 years. You know. Here is November 91. When she always came into any radio event.
Is that you?
That's me.
With the hair?
I'm using something here, you know, to cover the head. Now is the question and answer section. So I would like to know how can I help you, and then answer if somebody can have any answer to. Let's go.
Is the signal directional along the loop or broadside to the loop?
Okay. You know, I'm very good, you know, and let me put it together because I have reset it. Now, I will say that the way is like the circle here is on the circle you have on the direction of the coax you have the best position, and 90 degrees like this. Let's suppose the coax is here, okay? The coax is the best position. At this part you have the loop, okay? Yeah, let's go.
That's the question. I think of something round that's got metal around it, a bicycle tire.
Let me understand it. I have two problems. I have a listening problem and an English understanding problem.
A bicycle tire as the outer
Bicycle rim.
the bicycle rim.
A bicycle rim, oh, okay.
Have you ever thought about, did you try that?
Yeah, no, many people, if you put bicycle rim magnetic loop, you'll find dozens of people who have done this, you know? So you can get your idea to destroy your bicycle, okay? Any more? Okay.
If you're at 3 feet, if you're at 3 feet high with your loop,
Yeah.
and you have a signal, now you somehow grow tall and you're 40 feet tall.
Yeah.
How much stronger is your signal at 40
Okay,
feet?
great question. The magnetic loop is the only antenna that will need only 3 feet above the ground to work perfectly well. You don't need counterpoises, nothing like this, and only 3 feet is enough. What will define what will be The situation is the environment, if you have tall buildings, if you have something like that. But if you are on a field, on a place that there's nothing beside you, you can use it 3 feet above the ground or 10 feet that will behave the same.
I got a question about the loop.
Yeah.
How did you connect the shield? Is it crimped or soldered? And another question, you connected the center conductor.
Yeah.
Does it actually make a difference because the RF should travel on the shield?
I connect the shield. There are many people that only use the brake. But I connect the shield with the inner connector just in case, you know. I have this possibility. I make this to reduce the internal resistance of the connector. We talk about the skin effect, that the current only circulates on the outer side of the brake, but I make just because I feel better, you know, to know that I have a lower resistance, and I have a lower resistance to improve the Q of the antenna. And you have another question.
There's a shield. How is it connected? Is it trimmed or is it soldered to the connector?
No, actually, I'm using on my antennas a monoblock connector. I take a manufacturer in Brazil, and it has to make for me a completely metal block connector. It's the first time that somebody makes this. And I asked somebody in Brazil to make the gold plating system over this connector to avoid corrosion. Because plate is a better conductor than gold. The plate forms something like an oxidation in contact with the air, and very, very few days or months you will have a great resistance on the connection. So this way I use gold to warranty that you have no oxidation problem, and you improve this over the time, a better contact, electric contact.
Two questions. First one, is the limitation,
There is a barrier, wow.
Okay.
Deixa o microfone aí, vai lá.
Power limitation.
Deixa o microfone aí, vai lá.
Okay. Is the power limitation primarily because of the variable capacitors breakdown, voltage breakdown?
Okay, let me go there.
That's one question.
Now, the second one.
And the second one, will the mat loop be available as a commercial product?
Oh, great.
Okay, I start with the second question. You were asking about the mat loop will be available. It's just one of my experience to like a self-challenge to my capabilities to do something different. And you have another great fan of the mat loop is Bob Allison from AWRL. He loves the mat loop and is waiting for the day that it will be available. And the other question that you have made is about the power limitation of the magnetic loop. The power limitations is defined by the spacing of the plates, you know. You have a bigger plate spacing to have more power on your loop.
If the capacitor starts to arc, will you hear it through the plastic box? And
If you start to?
if it starts arcing, if you do you hear it through the
Sound?
Yeah, will you hear it?
It's possible to hear it. Yeah.
He makes a question that if the variable capacitor start to give it the sparks, you at the high power, this sound will be heard, will be listened, right? Yeah. So I have some sparks on my experience, and I don't know. I figured, but you know, it's something a little bit. Small compared to this, you know, the shockers that, you know, that police use. It's something like this, but on a very small scale. You know, I'm not using a very big power, you know, but the space is little. I have a little spark, but when you put a great quantity of power, it will make a spark.
Will this cause permanent damage, like little traces that will...
Yeah, of course. This can. If you probably have a lot of power on an antenna like an Alexloop, you have 100 watts, 1 kilowatt of force, the spark will melt the aluminum and solder the plate. So you have now a damaged variable capacitor. We can do nothing more with this.
But if it arcs just a little bit, so will there be like traces that it will arc more if you?
I don't know. You need to have a capacimeter and try to know what was the size of the damage, or even you lower the power or the RF on the right time to have no damage, you know. You know what I mean?
Yeah.
It's just a case of try and see what is wrong with a capacimeter. Any more? Nothing more. So I will thank you very much for this fantastic audience of people that are interested in my lecture. I have some seconds to talk. I have this new Alexloop premiere that will be on the market probably in more 2 or 3 months. Is what I call monoblock gold-plated capacitors. That is my feeling of reduce much more the internal resistance of the Alexloop. And the other product that I have put on the market is the Alex mic. The Alex mic is a microphone with a speaker and amplifier inside to improve the audio from the KX radios. They're a fantastic piece of equipment, but as I am getting older, I am losing my listening capabilities, so I have developed this to improve the audio to be more comfortable. So I thank you very much for all of us. I see you again next year. Okay? Bye-bye.
Folks, if you would please take a minute on your way out and complete an evaluation form. We'd love to hear what you liked about the program, what we can do even better next year. Thank you very much.